Good morning to all. Today we are trying to speak something about QAQC systems which are prevalent in ready-mix industry, and most of you may be receiving concrete or producing concrete or using concrete in different ways. Just we will share some of our points actually about the basics of QAQC systems that happen in the ready-mix industry. Here we have two words which everybody knows, QA and QC. And the QA is more towards the confidence part that a ready-mix company or an organization or a producer builds into the customers, that if we purchase from this ready-mix company, everything will be all right. And this is done through several series of confidence building measures, series of procedures, series of implementations that happen to satisfy the requirements. QC, on the other hand, is like you are talking about the testing part and inspecting and reviewing things like that actually, which generally are related to the product itself. How the product is tested for its parameters, its performance, what are the parameters against which they are tested. That comes under QC part actually. Just a thought actually, that should we speak for so much about all these things about ready-mix concrete industry or the QAQC systems that happen in ready-mix concrete industry? This is the question actually. So as a joke, I just tell you that one of my cousins today asked, "Oh, you are speaking something on concrete? What is there in that actually? Just mixing something? Okay, it is some cement and things like that actually." So this is the perception that many people carry, not only outsiders who do not know the industry speak about, even many engineers speak in this language when it comes to concrete, because concrete is mostly a neglected product, even though it is used largely by everyone throughout the world actually. So my answer was, as we go deeper into any subject, whether it is ready-mix industry, concrete or admixtures or whatever it is, any subject for that matter, the deeper we go, we understand that we don't know anything yet, and we need to know a lot of things actually. So that is how in the field of concrete we operate from some known things actually, and some known things in ready-mix concrete we apply with our experience a set of procedures which are called collectively as QAQC system to ensure the end quality of the product. So quality, when we are talking about quality, it is not some new invention or something like that. Several people have worked for a long time actually, and in fact about 700 BC, Chinese had a comprehensive set of standards, and they were doing inspections, training, and which were giving rise to many repeated productions. So it is not new that the quality systems and things like that. So we need to figure out what is happening actually. So So in about 180, usage of concrete, huge walls and domes started actually. In 500 AD, Romans were manufacturing bricks for use in construction, and they were making stamps. They were making stamps. Throughout the history, the Romans utilized the building yard approach to organize construction into trades. So they were having this system of first wall, then frame, plaster, and whitewash, things like that. So I'm fascinated by these things actually. Long back, the systems they had, for example, this Temple of Sun in Machu Picchu, Peru, constructed around estimated to be in the 14th century. You can see how these stones have been organized actually. It not have been possible with a very strict, stringent quality standards and planning and things like that. Similarly, uh, people are dumbfounded. People are dumbfounded if we see these pictures. For example, this is a granite box found about 200 to 300 feet below the ground level in Saqqara in Egypt. Actually, you can see the polished surface, how smoothly it is done. It is about 85 to 90 tons. So here we can see how perfectly at that time such a beautifully polished surface was achieved. About this is about between 3,000 to 4,000 years ago, as the age is estimated actually. So 3,000 to 4,000 years ago, they had such quality standards actually, and we have to remember here that the stones are not moldable like concrete is actually. So we can make concrete and mold it into different shapes actually, but stones are not actually. So at that time, if they had reached such a precision uh, in terms of making huge structures, 100 weighing hundreds, thousands of tons actually. Some of the statues in Egypt weigh thousands tons, 1,000 tons. So so very high degree of quality control and quality control management and management systems and these things were there already long back actually. And it is in the modern days when we have concrete which is more, you can say, flexible in terms of usability. We should be making giant strides in terms of our quality control and going towards better structures actually, when they had done so much better at that time with a difficult material. Means difficult to chisel out or difficult to shape, difficult to polish when compared to concrete actually. So when they can do such things 5,000 years back, 4,000 years back, so we are definitely equipped to do better because, as I said earlier, concrete is more flexible material in terms of molding. So in an organization, especially a Readymix company, you have a whole range of quality management systems. The quality management systems include sampling and testing of concrete, plant and field control, personal training, user education, evaluation, mixture optimization, very important, research and development, specification review, evaluation of concrete performance, and analysis of failures, if any. So this is a whole, as a whole, this represents QQ system in a Readymix company. So Readymix concrete, it is very easy. It looks easy actually from the outset for an outsider, but it is complex because you need to have stringent quality controls systems, QC systems from in 3 levels actually. One is forward control, another is immediate control, and retrospective control. Forward control is generally set of all activities which are done prior to production, prior to production, which are more towards the QS side, more towards QS side, uh, which defines and lays foundation for the other things that happen in the ready-mix concrete company or the producer place. So immediate control is set of activities that happen at the point of production. Retrospective control happens later, and this is set of all activities that happen after production and which cannot be done before production. So we have a reference standard IS 4926, which beautifully lays all the parameters for QC systems for ready-mix concrete. Once we are into a ready-mix company, you need to have materials to for production. So you have a purchase system actually, and once you finalize some vendors or suppliers, the suppliers can be once you are finalized with the suppliers, you get some materials you should lay importance to or give importance to visual checks, whether we have to accept or reject each truck which comes in. Then each truck, or as per the frequency set in, we have sampling and testing of the incoming materials. Certification from suppliers are required actually. Unfortunately, in India, we don't have certification from aggregate or sand suppliers. We need to test ourselves actually. In abroad, other countries, we have each truck or each consignment supplied from coarse aggregate or fine aggregate supplier comes with some assurance, comes with some certificate on demand actually. So information from suppliers is very important. We need to get information, timely information on each consignment. Most importantly, we have this problem actually. The vendors are not treated well actually. Vendors are treated badly in this industry, except a few companies. Vendors are just paid to supply and probably made to wait for their money and things like that, and they are not respected actually for the contribution that they do actually. The success comes from recognizing suppliers as partners and a valuable integral part of Readymix. If we, when we recognize them as their integral part of our business and their partners for us, then it becomes easy, and we have continuous interaction, and probably they will contribute in a better way to improvement of overall quality. So when we are purchasing materials, the trucks have to be weighed actually. Purchase basis is not random actually. It should be based on availability, product quality, long-term relationships are important with the vendor. You know a vendor who has served you for a long time, and whom you know that in any case of crisis, either in metal supply situations, bad situations of metal supply, or a crisis, or when the quality of a particular product goes up and down, how he reacts and how he has maintained relationship with you will also be a basis for purchase. Of course, material cost is very important one, and freight is very important one. For example, you have two products. For example, whether it is cement or cementitious materials or admixtures, you have two suppliers, one coming from 500 kilometers, one coming from 200 kilometers. Naturally, you will consider it a company which is serving you from a shorter distance. And how the vendors react to the your information that you give to them about the product, and how their quality control is and the support is also forms the basis for purchase of material. Some suppliers, whether it is admixture or cement or something like that, they don't respond if you give a small information about the variation of the product or something like that. So these kind of things will form a basis for future dealing with that kind of suppliers actually. Material storage is a very very important aspect, and once the materials are received, the aggregates have to be stored in properly in their respective bins actually, and there should not be intermixing of aggregates, whether it is fine aggregate or coarse aggregates, and bins have to be marked actually, and there should be a separate space for rejected materials. So identification of silos which are meant for storing different cementitious systems like fly ash or GGBS or OPC has to be marked actually, and the batcher and the QC people should be very clearly able to identify which cement or which material is in which silo actually. There should not be any case of intermixing or contamination of one product to another product, which may cause a disaster actually. Traceability is very important. Traceability, for example, from the receipt of a material to the delivery. For example, today we have done some concrete actually. So we should be able to exactly demonstrate to an outsider, an auditor, or a customer, or anybody for that matter, if they come and ask us actually, whether we have used what kind of cement we used, what brand of cement we used, and what aggregates from which source we have used. So traceability of all the ingredients from a receipt to the finished good should be a very important and integral part of QAQC system actually. So for this, what we do is one of the things that we can do is to take a batch record, connect it to a invoice or a TC, and connect it to a mix design, connect it also to the slump and strength report. So there is a connectivity from receipt of the material to the end, connect to the MTC of the cement and GGBS and things like that. So there should be a tracing of from the receipt until the finished product. So mix design and mix design modification is very important part of the forward control. This is done based on data and trials, and many companies will do annual strength versus water cement ratio trials actually. Okay, so we have a set of trials with set of cement contents starting from maybe 300 to 500 actually, and different water cement ratio we take, and then we see whether the different grades are achieved at what points actually. This lays a foundation for our mixes to come every year. So we can do this actually in lab to establish a strength versus cement content curve actually. And we have to understand the customer, what customer wants actually. Okay, so intended use is very important actually. Okay, so if we don't do this one, we will be heading into disaster actually. Like for example, we had a problem long back where customer asked M25, we gave M25, and after 1 year he calls that dusting is taking place. So a lot of material is coming off from the concrete floor. And when we went and visited, a lot of wheelbarrows they were using, and a lot of heavy vehicles were going on the floor actually. and this was not told to us before we supplied the concrete actually. So if that if a person customer is having intention of using floor concrete or making a industrial floor, he should go and he should discuss with the producer what he wants to use this concrete for, and then also probably have meetings with the structural consultant to specify a minimum grade with a specific kind of concrete, type of concrete actually. Otherwise, it will be difficult actually. And understanding these requirements from the producer is also equally important. We need to understand as a producer completely before we submit the mix. And after that, we offer the mix to customers, and there is validation of mixes. Okay, trials can be done. We have to validate the mix actually, and we have to arrange the mixes. We have to organize the mix. There are several kinds of mixes. For example, OPC, GGPS mixes, OPC fly ash mixes probably, and OPC mixes alone, and some specified mixes. All these have to be organized. Okay, and this is very important and part of uh, quality control system. Plant maintenance is very important actually. How the uniformity of the mix comes in. Central mixer has to be maintained. Truck mixes have to be maintained. DG has to be maintained. All this maintenance have to be done in a periodic schedule, with a periodic schedule and with checklists. All these instruments or all this equipment have their own checklists actually, either given by the manufacturer or the Readymix company themselves can develop these checklists, and maintenance has to be done in time without missing actually. It is very important to keep the transfer and weighing equipment in perfect condition. There should be controlled flow, calibrated weight scales should be there, calibration and scale check has to be done. There is a difference between calibration and scale check. We do calibration every 3 months, and we do scale checks every month actually. So calibration is setting of the weighing scale, weighing equipment with the load cells in a such a way that the exact weights are exhibited actually, and exactly the weighing system works actually. If there is any small variation, then the electronically this is set actually. This is called setting up the system or calibration actually. Scale check is a random check actually. Randomly some weights are put, and we check whether the weight put on the weighing scale or the system is exactly reflected in the batch computer. This is scale check actually. So there is a difference between these two actually. But as a producer, it's most important responsibility of the producer to see that all the instruments, especially the batching plant weighing scales, are in order, and they are calibrated in the frequencies as specified in IS 4926. And if from the receiver side or the customer side, the first thing that a customer checks when he walks into your plant is whether the calibration is done in time or not. Calibration of admixture dispensers or calibration of admixture dispensers are very important actually, because admixture dosage is very important, and if there is any big changes in admixture dosage, for example, if the admixture goes in 1:2 or 1:1.5 or something like that than the specified or the intended dosage, then it will cause problems to the concrete. So calibration of admixtures has to be done probably once in 15 days or something like that. Plant mixers and truck mixers have to be in good condition. They have to be maintained, repaired as per schedule. Blade condition is important. Mixer power. If there is a lot of accumulation of the old debris, old concrete set on the walls of the drum, if it is not removed in time, if it is not chipped off in time, if it is not cleaned in time, the mixer power will increase, and it is a waste of money and resource actually. And also it may lead to some of the quality problems actually. For example, long back we had a customer where we were supplying M40 concrete. This is I'm talking about 15 years back. where we were supplying concrete, M40 concrete, and then a lot of these lumps came out, and he asked, "What is the quality that you are talking about? You talk all this about quality, and then you supply such kind of debris or some old concrete, set concretes, which comes along with the new concrete. So, what is the kind of quality control that you are exercising?" This is the question. So we had no answer at that time. So it is very, very important to see that there is no continuous build-up and monitoring of chipping, and these operations of maintenance is done regularly. Production control comes under immediate control, which is the next step actually. For example, we know that you may have selected the best cement, best admixture, everything is best that you have selected actually. But if your production system procedure or the QAQC systems are not properly exercised at the point of production, then it will lead to problems in the final product actually. So what are the activities that we do at the point of production, at the time of production, is very, very essential. We need to also know here that quality of components or the ingredients, some of the quality of the ingredients will not give or ensure the total quality of the product. Quality of individual products, individual components may be good, but it may not indicate the final product as best product unless otherwise we go through a proper and stringent immediate quality control system. So here, the first step that we have to do in immediate control is whether the moisture is fed or not. Actually, moisture is fed into the batch cabin or not. Every day, especially in monsoon, 3 times the moisture is taken. Otherwise, at least minimum 2 times the moisture is taken on all the aggregates, whether it is fine aggregate or coarse aggregate, and this is fed into the batch computer. Or if there is a problem that we cannot feed directly into batch computer, we need to correct the mixes as per the moisture and then give it to the batch computer. So giving moisture is to the batch cabin is important, and we should ensure that this particular moisture is entered in the system of batching actually. So weighing is very important. Whether the exact weights have been weighed or not, which will be reflected in the batching data, we need to check actually. Visual observation of concrete during sampling and testing for assessing uniformity, cohesion, workability. And we need to sometimes make adjustments in water content actually. For example, we have taken moisture from the bins yard. If you have taken from the yard, the moisture may be different, and the bins, loading bins, which are directly going to feed onto the main systems, these two may be having different moistures. So we need to be careful about this one, and some small adjustments have to be done after seeing 1 or 2 batches. Each batch may be 1 cubic meter in a M60 plant or half a meter cube in a M30 plant. So these corrections are very essential. Sampling of concrete has to be done randomly actually. So every company has its own QCsystem system. So some companies, for example, some companies abroad check every truck actually. Some companies check once in 3 trucks or once in 4 trucks actually. That depends upon the quality plan that they have actually. But we need to check the slump at the plant, and it has to be recorded. And measuring temperature at plant also is important. Even though we have not given much importance to the temperature here, we know that concrete generally should not be used at or placed at very high temperatures. It is recommended that concrete should not be having a temperature of more than 40 degrees at the placing point actually. And also in some specifications, they say that concrete should not be done when the atmospheric temperatures are beyond 38 degrees. If such temperatures exist, we need to go through a different procedure of production where we incorporate ice or chilled water and make the concrete cooler when it reaches the site. Actually, the temperature of concrete at site may be 27 or 28 as per specifications, especially for mass foundations. The temperature is of very essential property, where the heat build up and things like that we have to take care. And from controlling the cracks and evaporation losses, also temperature is very important. Also we need to be very careful about the temperature when we are doing high cement content concrete mixes. Actually, if the concrete is M40 M50 where the cementitious contents may be more than 450, something like that, like say for example 430 plus 20 kg microsilica alkafine or something like that, in those situations where the heat of hydration and the reactions are going faster within the body of concrete in the initial stages, the operational losses will be more, so the temperature has to be controlled. But we need to be careful of another point actually here, that if anybody specifies the temperature, actually if the customer specifies temperature at the point of placing, we need to educate him that it comes with a cost. Actually, we need to add ice or we need to add chilled water or things like that. It is also important to know, we need to important to know that higher the temperature, rate of hydration is more, heat buildup will be more, and at elevated temperatures, the strength gain will be stunted actually, especially the ultimate strength will be stunted actually. So you may get the strength faster up to 7 days, but after some time the strength gain will not be good actually, and it will not reach its desired or potential strength. So that is the reason concreting at elevated temperatures, high temperatures is not recommended. So we need to be having a tab on this. Actually, we need to be monitoring this also. But this is not a practice only in some big projects in India. We take care of the temperature. Otherwise, nobody asks about the temperature, and so many of the companies are not bothered about measuring the temperature at plant or site. Keeping some sample for checking slump retention. So this is to analyze what is happening with the concrete production. Okay, part of it will be the immediate control, part of it will be retrospective control. So here we check some sample and keep it, so that after 2 hours what happens to the sample, whether the slump is retained or not, that we check. So retrospective control is set of all activities that as we discussed earlier about which deal with all the aspects that can be done only after production actually. So like taking slump at site, and then casting cubes, curing, these points which can be done only after producing the concrete. These come under retrospective control. So some of the tests, we have moved partially to an age of SCC. So we have these SCC tests where the flow has to be measured, not only at the point of lab during trials and during production, but sometimes required at site also, where the flow should be between 650 to 850. And YouTube test where you keep the concrete in one column and rises in the other column, and the difference should not be more than 30 mm. L-box test, and then V-funnel test. So these are some of the tests that we do post-production, that is retrospective control, and all this information has to be passed on to QC department. Okay. Next, a very important point actually before we move into, or before we discuss as earlier about SCC. The procedure of sampling is not observed by many people, many concrete technologists actually. There is a very well laid procedures in BS, where they say the concrete truck once it reaches the site, you have to leave the first part and the last part, that is first meter cube and the last meter cube, and then you need to take the concrete sample in between when the concrete is flowing onto the pump actually, and the scoop has to be moving at right angles to the flow of concrete. The people who have made this kind of code have gone to such level to define the dimensions of the scoop actually. They are very particular to tell that so many scoops have to be taken for making so many more tubes. Okay, and why this is required? Why this is required is we have to remember that from a 15-ton truck or 16-ton concrete, where there is 15 to 16-ton of concrete in a truck actually, we are taking a sample of like say for example 6 joules means 6 into 8 or 9, about 50 to 60 kgs of sample we are taking, maybe 70 kgs of sample we are taking. So it is not easy to take a representative sample. So there are two methods defined actually. One is a composite sample, or the first method, standard method, where we leave the first one portion and last one portion and take the slumps in between. Sorry, take the sample in between in scoops actually, 1, 2, 3, 4, okay, like this actually. When the concrete is flowing and falling onto the pump actually. So this can be used for making cubes also. There is another kind of sampling which is called as alternative method, where customer or somebody wants to just randomly check the sample actually, of the concrete. Here 0.3 meter cube is left, 0.3 meter cube is discharged, and then after discharging 0.3 meter cube, then we take the concrete sample and slump is measured actually, or the workability is measured, and this they say should not be used for making cubes actually. This should not be used for making cubes actually. So now the other method, ASTM, also follows the same method actually. They say first 15% has to be left, last 15% have to be left, and in between we have to take the concrete. Before that one, we have to remix the truck actually. Several revolutions have to be done before we start taking the unloading the truck into the concrete into the pump and taking the sample actually. Now, whereas now we have moved to Indian standard, when we talk about the Indian standard, we say that here 0.3 meter cube has to be discharged once the concrete is uh, thoroughly mixed in the truck. Once it reaches the site, thoroughly mixed, and when it is moving on to the pump, for first 0.3 meter cube has to be left, and after that you take the samples in 4 incremental samples have to be taken. So, so we know the differences actually. We know there is a difference between these standards, but at least we need to follow the Indian standard, okay, where we talk about leaving about 0.3 cubic meters, okay. So this is very very essential, as I said, because we are talking about representative sample. So if somebody says no, I want to take in the middle, I want to take at the end, I want to take in that way, this way and all, that is not a proper procedure and that is not as per standard. The answer is very very simple, that we cannot do like that because this is not defined. Like say for example, most importantly, you know, we have the we comply everything when we talk about steel. We comply everything when we talk about other metals. But when it comes to the standards of ready-mix concrete, whether it is sampling or testing or something like that, we try to be more creative and probably define our own methods. So somebody says, I will do this way. Why I should discharge 0.3 meter cube? Why I should discharge 1 cubic meter? I will take sample whenever I want. These kind of arguments will come into picture. the only answer that can be given to this is that these standards have been made by people with a lot of experience after taking and studying thousands of samples, so from thousands of trucks all over the world, not only in India, in many parts of the world, and it has to be strictly followed. So what do you do if the slump is less? See, as per IS, the allowance given is plus or minus 25 mm or one third, whichever is lesser. If the slump is, for example, we have a slump at site requirement of about 150 mm. We have an allowance of plus or minus 25. So this is the slump range given. Okay. So if it is less than this, maybe if the slump comes on less 100 mm. So we have an option of using a chemical admixture. The chemical admixture can be added at the point of placing. Just you add about say about 0.1% or 0.2% of the by weight of cement to the entire truck. Generally, it is about half liter to 1 liter per cubic meter. Sorry, half liter to 1 liter, which can be diluted in about 5 to 10 liters of water, and it can be added actually. So this is going to work as a booster. Only thing that we have to take care here is we need to remix the concrete thoroughly and don't unload, because suddenly if you unload, then it may cause segregation actually. So this is already recommended in ACA. Okay, this is also recommended in IS 4926. Properties of concrete. A.M. Navile has written a lot about this, and many other authors have also written about this. And this is a time-tested procedure actually. So somebody says I will not allow and all. That is some people want to act as per whims and fancies. We don't have answer for such people actually. So the procedure given here is slump. If it is less, we can boost this slump. I want to bring to your notice that we have the other standards, European standards, BSEN 12350, where there is a tolerance is given based on slump class, where the slump class is S4 and S3. For example, S3 is you can take the concrete between 80 to 170. Means there is a scope for the producer to deliver between 80 mm to 170 mm. Okay. Similarly, there is S4 class where a concrete producer can deliver the concrete between 140 mm to 230. So this is a more proper, I can say, uh, practical way of delivering the concrete. The only point of talking about this one is just rejecting the concrete or just not accepting the concrete based on 25 mm or 30 mm variation is really, it is a, you can say, a kind of a waste and unjustifiable activity, because each truck will contain, say for example, 300 kgs into 6, about 1,5 tons of cement. It is a national waste actually if we just reject based on slump. Okay, so we need to think many times before we just go through exactly the slump and reject the truck based on the slump actually. We have a slump booster. Here we need to also understand that the class F type of admixture has to be used. Most of the ready mix companies, many of the ready mix producers don't go for different admixture for addition on site actually, but it is ideal to use class F type of admixture where there is no retardation effect. Okay. So if the slump is more than specification, for example, slump is more than specification, it can be more water, can be because of increase of coarser materials, maybe increase of chemical admixture, maybe a wrong batching, different cement, or same brand with different properties. So here we will definitely have a beautiful problem with the brand to brand and same brand giving different slumps actually. Okay, so unfortunately, many times ready mix companies cannot recognize, even the cement companies cannot recognize, or even if we recognize sometimes also. that is not encouraged to be to recognize it. Okay, so there is a lot of variations happen actually, and it is sometimes a nightmare for QAQC people in the ready mix companies to deal with different brands of cement, and some brand of cement coming with different plants actually. So these things have to be taken into account actually. Check before accepting actually, as a person on site, from the client side or the customer side, we need to think about all these things, whether it has happened. If it has happened because of water, definitely it stands to be rejected. Definitely it stands to be rejected. There is no way about other than this. So making of cubes has been clearly described in IS 516. Okay, uh, very very important actually. So here trained technicians have to be used. Trained technicians have to be used. Okay, 35 strokes each layer. Okay, so we are talking all these things because everybody knows all these things. Everybody in site, all the civil engineers are aware of this one, but unfortunately, many times we don't practice it. That is the reason we need to talk about this several times. Actually, yield check is very important. Actually, we get several times complaints coming from customers talking about yield of concrete or something like that. Okay, here the answer is that we are following the standard procedure of checking yield actually. Okay, where a standard container is taken 10 liters. Okay, and for every 5 centimeter one layer. Okay, 60 strokes concrete is filled, and 60 strokes is spread actually. Okay, so 6 layers or something like that. 5 layers is done. 250 is the height of the cylinder. So 5 to 6 layers, it will have about 60 layers, 60 strokes on each layer. So we take the weight of the container with concrete, weight of the container without concrete, and then divide by the volume. Gives the uh, plastic density of concrete actually. So this gives the plastic density of concrete. This plastic density of concrete should be very close to or equal to theoretical density of concrete. What is theoretical density of concrete? Theoretical density of concrete based on the mixed proportion or mixed design. And plastic density is the actual density of concrete when we are checked as per IS 516, sorry, and IS 1199. Okay, so here once we check this one, also we also check the weights of the different ingredients of concrete. So what is the total concrete in the truck? So empty weight of the truck, full weight of the truck we take, and then find out what is the total concrete available in the truck divided by the volume bagged. So these two things have to match actually. What is the things which have to match is, one is theoretical density, plastic density, and the weight of the concrete in truck divided by the volume. All these have to be closer actually, and we have a allowance of 0.98 to 1.02. So the yield has to be 0.98 to 1.02. Why yield has to be between 0.98 to 1.02 is basically because the weighing system as per Indian standard IS 4926, they give that cement allowance for cement variability tolerance for weighing is plus or minus 2%. Other metals, whether it is 20 mm, 10 mm, sand, admixtures, water, plus or minus 3% variation is allowed. So when the weighing system itself is allowing plus or minus 2% and plus or minus 3%, the final product when we weigh also will have a tolerance of plus or minus 2%, plus or minus 3%. This is the tolerance of the scale. This is the tolerance given actually. So yield is also based on this one. So whenever we have this kind of complaints or something like that about yield or something like that, we need to say and demonstrate to the customer consistently we are making this yield test in our plant, also we need to show all the documents related to this. So there is a difference between, for example, it is very easy to say that things are easy and just put a ready mix plant, about maybe 70 lakhs or 80 lakhs, and set up a very fancy building. Actually, set up a very fancy building and things like that. Like a hotel, you have a hotel, okay, where all the chairs are decorated and tables are arranged neatly, actually, and somebody will give you an information, oh, the biryani is very good, actually, okay. So we go there, everything is assured, actually. The people, the servers are very well dressed, actually. Everybody's plates are clean. So it's very easy, okay, we just believe and take the food, actually. But what is important is we don't go to the QC part. QC part is we don't check whether the food items, the ingredients, for example, what is stored inside, whether it is expired, whether it is fresh product, old product, new product. We don't check whether the chef is sick. We don't know, actually. We just believe and go and eat, actually. Okay. So these things keep happening. But when we come to Readymix company, same thing from point of receiving of materials until the production, we need to be very careful on each step, especially when we are making the taking the sample and making cubes and testing. We have to be very, very careful because it will lead to a lot of later on thoughts and discussions, and we'll be breaking our heads. Okay, so these steps have to be taken very clearly and understood very clearly to ensure that the final cube results, which probably are many times only one proof for us, for a ready mix producer, to say that he has supplied the reed concrete. Actually, that is the only proof many times we have to we have to demonstrate to the customer. We have to demonstrate to the customer. So in such situations, we need to be very careful about the key aspects of sampling and cube making. Okay, okay. Uh, not by just putting up a big plant and having a very beautiful decoration of the plant and things like that. It is not that. How the people are trained, how they are taking care of each and every step of QC is important, actually. Representative sample from truck is very important. Remixing the sample is very important. Standard cube molds, oiled, assembled, very important. Full compaction. We know that each uncompacted 1% of concrete will lead to 5% or 6% loss of strength, actually. Maintaining cube mold, curing cubes under standard conditions, observation of cube faults, accurate measurement of dimension and weight. Okay. And for example, density, it is said that we should have the dry cube density should not vary between plus or minus 50 kg per cubic meter in a set of sample, actually. And also it should not be more than plus or minus 75 kg per cubic meter of the fresh density of concrete. The dry density should not be more than plus or minus 75, and plus or minus 50 kgs is recommended variation in the cube density between a set of cubes. Means one, when I tell set of cubes, it is set of 3 cubes, actually. So these are some norms set, actually, which need to be considered, actually. Now we have a very, very important aspect, okay, where we talk about target mean strength, which is the design strength, actually, and we have cube strength, okay, and then field strength. So field strength will definitely vary based on many things, actually. Okay, field strength will vary based on many things. What happens in transport, how somebody is compacting, something like that, how the customer is curing the concrete on site. That determines the field strength. We are talking about cube strength, actually. Cube strength means where the cubes are cast as per IS, cured, transported, and cured in water tanks as per IS. So this is cube strength. field strength is there. So cube strength should be closer to the potential strength of concrete. What is the potential strength of concrete? Potential strength of concrete is something like target mean strength, target strength. Okay. So we many times find results totally away from target strength. Okay, means for example, if the concrete is M20 and if the target mean strength is about 26 or 27. Okay, here we may have a concrete ending up at 22 or 23 or 21 actually. Okay, so a concrete which has a potential to reach 26 or 28 in trials, it has reached say 30 also, but it has reached when we take the cubes, it might have reached 22 or 23 actually. So why this kind of thing happens? This is the differences that happen because of variations that occur in the steps that we are going to talk now. That is, a sampling error will lead to some deviation, which is about plus or minus 10%. Failure to remix the sample, very, very important actually. It is negative, it will give about 15%. Distorted cube molds or lack of oil, incomplete compaction can be totally negative, 20%. Curing temperature outside the range, lack of continuous moist curing, which is about 35%, it can give. Faulty cube location, faulty test machine. So all these things, factors contribute to variation in the cube strength. Okay, variation in cube strength means variation from the potential or target strength which it would have attained if we had done properly. If all the activities were done properly, we would have attained say 32 or 33. Okay, and the target mean strength is about 26 or 27. Okay, but we are going to get about 22 or 23, very close to characteristic strength, maybe because of all these things. I'm not talking about the field strength. Field strengths are different actually. So we have to analyze these things if there is any problem with respect to strength actually before we go to the next step. Okay. So unfortunately, what happens in field is this kind of approach is not at all done actually. Just if there is any cube failure or something like that, go to the next step. What is the next step? Go to the code strength actually. Okay. So this is not the right way of doing things actually. We need to follow these things. This is part of the QA/QC system. Okay. And both the producer and the client or the customer need to understand this one. It is not a one-way traffic actually. So curing has to be done at 27 plus or minus 2 degrees. IS 4926 gives clearly what is the information to be provided, complete information to be provided by the producer. Okay, and annexure, there is a clear annexure annexure G, which says how the DC or the invoice which goes along with the truck is to be there actually. So exactly we need to follow that one. Okay. So what are the checks that we have to do once the concrete reaches the site? Metal should be as per IS 456. Metals testing has to be as per the frequency of 4926 and may be well defined by the company quality manual. There should be steps for batching plant to prevent contamination. Is it there? Calibration of batching plant is done in time as per the frequency. Maintenance of batching plant is happening. Calibration of lab equipment, all the lab equipment, CTM, things like that has to be calibrated. Checks at batching plant, checks at site, and together with that, the comprehensive QMS, which consists of forward, intermediate, retrospective controls. Delivery tickets should be as per IS 4926, and the batch records. If given to the customer, it should be clearly readable, and what kind of materials and ingredients producer has used, customer should clearly understand. And there are ready-mix plants which are using different methodology and different kind of coding systems, probably to depict what they're using in the plant. Some people don't exactly clearly mention what they have used in the batching plant, and uh, their batch records are not understandable by customers. So customers need to be aware of all these things actually. And there is definite guidelines for all this in IS 4926. We are not talking something which is not there in IS 4926. So all the QA systems of Readymix company has to be there as per IS 4926. That is the only important thing which we are following here. And we have as a retrospective control, the next is statistical quality control. There is mean, standard deviation, coefficient of variation, QSum method. So here at the end of every month or periodically, especially after every month, at the end of the month, we take about 30 results, last 30 results, and then find out the mean, standard deviation, things like that. And we have, if the standard deviation is between 2.1 to 2.8, around, say, for example, you can see 3, it is acceptable, 3.5 to 4.2 is fair, and above 4.2, if the standard deviation is there, then it is poor actually. So we need to be aware of this one actually, and every month we need to be monitoring for the different mixes that we are producing, or different grades of concrete that we are producing. What is the standard deviation? Okay, and we need to know here cement, brand to brand, batch to batch, same brand, different plant. Okay, aggregates, different sources, different quarries, sampling testing, non-standard and banned practices, production where the water cement ratio, moisture correction is not done. All these things contribute, and most importantly, cement and aggregates. Cement and aggregates may account to 50% of the variation in standard deviation. Okay, standard deviation will be affected to a degree of up to 50%. Possibility is there where the deviation can occur because of the variations in cement and aggregates. We need to be aware of that. Aggregates, when we are talking about aggregates that can contribute to the standard deviation, because the slumps will change if the fineness changes, especially 150 microns and some below 75 microns changes. If these fines means fine particles in the fine sand or the fine aggregate, if it changes drastically, it will lead to slump variations. For that, we need to either increase the water content a little bit or something like that, and it will contribute to the strength deviations actually. We have what is called as QSum method, which is also called as cumulative sum method, where it is a statistical tool to control the strengths of concrete. It is a predictive method, so where the strengths of 28 days are predicted based on 7 days strengths that we get actually. But applying this tool is not very easy. We need to have control on all the materials. There cannot be too many cements, too many ingredients, and it will apply to a family of mixes. One family of mixes means a mix with same kind of ingredients, actually, same kind of ingredients where the sources, everything is same. So it is not a very easy tool actually, and if the variations occur, bad results come, and if we enter the bad results into this software or do some system actually, we end up in getting different controls, and it may lead to some uh, different understanding of where we are getting into. So it is not easy to apply unless otherwise you have a very strict quality control system, and your aggregates sources, cement sources and all has to be almost you can say single, and there should not be variations in your results. So we have the acceptance criteria. We will be checking our QCsystemsofreadymixedconcrete continuously on the acceptance criteria. Okay, whether it is meeting the acceptance criteria or not actually. So when we are talking about the retrospective control, we have an eye on designed mixes actually. A concrete producers will have a range of mixes which are obtained by trials, which can be based on previous data or similar ingredients. We need to evaluate, and then we need to evaluate as after production about setting characteristic material compatibility evaluation we have to do of workability, feasibility, uniformity, durability, things like that. Prescribed mixes. See here, what happens is when we are talking to a Readymix company, one is to ask them to design the mixes based on their experience, the data available, and things like that, and give the specifications that I need this concrete for moderate exposure or severe exposure or this kind of intended use. I want 7 day strength like this, 28 day strength like this, or 3 day strength like this. All these specifications you give and give the freedom to the Readymix company, concrete technologist or the designer to do the design. On the other hand, you have prescribed mixes where just like a medicine is prescribed by a doctor, the client will say, I want 400 kg cement, water cement ratio 0.39 or 4.4, and then you have 20 like this and all. This is called a prescribed mix. Here, what happens is he is tying the hands and legs of the Readymix company, concrete technologies, and many times such mixes will perform badly in terms of both fresh and hardened properties. And earlier, uh, it was set in other country, I mean, especially the European codes earlier, long back, that the responsibility of the producer ceases once he just mixes and gives what is prescribed completely. Okay, if the customer prescribes everything and gives to us, gives to a ready mix company, you mix like this and give. These are the ingredients. This is the mix design. So the responsibility of the producer just closes if he just mixes and gives. He is in fact not responsible for both fresh and hardened properties. He will only have to ensure that he has mixed and given as per the specification. All the ingredients have been mixed and given. Okay, but unfortunately, many times it happens that after prescribing the mix, also after prescribing mix, also many of the customers try to put the responsibility of concrete quality onto the producer. This is a very bad practice, I can say. So what is the responsibility in this situation is that anybody who has prescribed the mix can come and check in the ready mix company whether same mix has been used with same ingredients, everything same as per the written document or written specification, written prescribed mix. So stock control is important because periodically when we are checking the stock control, we know that we have produced so much of concrete and we have utilized so much of concrete ingredients. So there should be a tally of these things actually, and there should be matching, and there should be not huge loss of material or huge gain of materials. Complaints is part of complaints and feedback are part of QAQC systems actually. Complaints can be workability related actually. Um, Everybody wants perfection in workability, but we need to understand that it is not a very simple task for a ready-mix concrete company to take the truck for travel, make the concrete truck travel for 2 hours and deliver the concrete at plus or minus 25. It is a very tough task actually. Why it is a difficult task? Just imagine the aggregate size that we use mostly is about 20 maximum size aggregate. So 20 maximum size aggregate, many times it can be 22 23 So one aggregate falls when the slump is being measured actually. One aggregate falls, just one aggregate, imagine it can give a plus or minus 25 Okay, variation can come actually. So delivering exact slump after traveling for a distance of 2 hours, or in traffic situations, 1.5 hours traffic in, let us say, in metros, if the truck travels for 1.5 hours or 2 hours, exact slump delivering is not easy actually. I'm not telling it is impossible. I'm not. What I'm trying to tell is it is not easy actually. Okay, so uh, we need to understand this particular point. There will be strength related issues many times. Service related issues also will be there, and these things, yield related issues may be there. And sometimes customers can come up and say the behavior of the uh, truck driver is not all right. Another customer can come and say your trucks were continuously coming, and we had no time to have a cup of coffee and a cigarette. So this can be kind of another kind of these kind of complaints also can come actually. Okay, so we need to identify customers. Okay, we need to understand that uh, customer satisfaction is important actually, and what is the perception that we are giving to the customers is very important actually, and what is the level of satisfaction we are giving to the customer is important. How we are managing our proposal, how we are managing quotations, everything is important. Ultimately, whether we are meeting the requirements of the customer is also very important. That happens if we have a very stringent QAQC system in place. It is important to promptly act on even the smallest of the complaints. Okay, so as I said, a silly example I gave actually, where I said that your trucks are coming continuously and you are pouring the concrete continuously, and I don't have time to even go and have a cup of coffee or cigarette. This kind of complaint also can come actually, but we need to be understanding every complaint of the customer and give top priority to the customer's reaction or feedback. And delays or inaction may result in further customer dissatisfaction, and ultimately it may be lead to costly litigation. Very important. So training is very important. As I said earlier, actually, whether it is a Readymix company or any company for that matter, actually, how the people are trained determines the ultimate quality of the product. Actually. So the training is very essential. The customer, each uh, employee has to be trained to make him best actually in the job that he is doing actually. He should understand exactly the job that he is doing, why, how, and when of the particular aspect of job that he is doing actually. Competency gaps have to be identified actually. What is the competency level of each employee that has to be identified? We have to enhance the abilities of the employees, and these things has to be taken to such a level that each employee should be working towards giving the best customer satisfaction. Until then, we have to be continuously training. So the training is continuous. It has to be designed in such a way to give highest level of customer satisfaction. Quality Council of India and RMCMA have made a comprehensive checklist to audit ready-mix concrete plants for capability in production. QSI certificate is highly valued, a very important point actually, and they have done a tremendous job, this RMCMA group and Quality Council of India. So the audits are done regularly. Once the audit is done, the certificate is valid for 3 years. In between, surveillance audit takes place every 6 months. So, the QCI checklist or the RMCMA checklist covers most of the aspects of 4926, which we are talking about here. So QAQC systems are generally designed to be preventative, means any problems that arise, how it arises, we have to be preventing that one. Predictive, we will be also predicting such problems. Some problem can come if we do in a particular way. So we have to be predictive, and there should be continuous measurable improvement. Okay, so it is not a stagnant. QAQC systems are not stagnant. It must have a continuous improvement component actually. Most importantly, we need to remember a component of continuous improvement is the creation of use of knowledge to continuously improve what and how to do, how things are done. So this has to be also observed actually. Collaborative. It is not one individual will do. It is each individual will work in collaboration with many of the people. Okay, to give the highest quality. On the other hand, each individual has to be trained actually. Okay, we need to understand. Bottom line is that quality we get is determined by each individual of the company. For example, we produce the best concrete. Okay, best mix design. Everything is done, and when the truck goes in between, the driver adds water actually. Okay, before the truck reaches, he adds water intentionally, knowingly, unknowingly, whatever it is, or some water leakage is happening in the truck. So each person has to be trained, including the drivers, and they matter a lot, and ultimately they determine the quality of concrete. So what contributes the to quality? Planning. So we have to put a lot of time in planning. Actually, there is a saying which says that a idiot and any idiot with a good planning, okay, can beat a genius who comes without any plan. Okay, so it is very important that we spend a lot of time. How much time we spend in planning, especially related to QA/QC systems and implementation of QA/QC systems, and measurement of quality, measurement of improvement of individuals in the organization. That that much there will be impact of these activities on the final quality. Skill improvement is very important. Schedule. If you have 2 minute schedule and your schedules are so tight and your resources are lesser, for example, then it will stretch your resources to such an extent that the quality of the final product may be a question mark. So we need to be careful about this scheduling and resources balance. Alignment and behavior. Each individual, for example, in a company, especially a Readymix company, which is where the operations are complex, and we have 3 pillars of quality control systems, from forward to intermediate to retrospective control. Each individual has to align himself with the company quality objectives and quality policy. Okay, and the behavior also has to be molded in that way actually. Also, nothing can be successful without the complete involvement of management, top management actually. uh, in this case, I just want to thank our company, our MD Shelly Fernandez, and Executive Director Mr. Ajit Kumar, and all the directors of the company for allowing me to speak to you. It has been an honor to speak to all of you, who are all very well experienced in the industry, and who have taken time to come and attend to this webinar. I'm thankful to you all actually. Any questions are there? You can ask. You can raise your hand, and we can discuss actually. Mr. Amarnath Pandey is asking one question: how ready-mix concrete may cost effective in view of maintaining quality and strength? Actually, see, ready-mix concrete, we have moved a long way in the ready-mix concrete industry from 1990s to 1996, and then here until 2020, where the cost is maybe just 5 to 10%, or even sometimes equal to a site fixed concrete actually. And here, Readymix company employs people, qualified people, many of them B graduates and diploma holders, and many of the people in the top management, maybe having 30-40 years of experience in ready mix industry. So all this ensures a very quality assured product, actually factory made product actually, and all these responsibilities of the quality, like we have been discussing about the entire QMS or QAQC system so far, is by just selecting a Readymix company, you have transferred all this to a Readymix company. It is the responsibility of the Readymix company to give the best quality as requested or required or ordered by you actually. So in simple words, you can say the cost of Readymix concrete is almost similar to a site mixed concrete actually. The advantages, Mr. Amarnath is again asking, what are the advantages of Readymix concrete? It is a factory produced product. All the ingredients meet the requirements of IS relevant standards actually, and all the ingredients are selected and tested continuously. Each batch, each consignment are tested actually as per to meet the requirements of IS relevant standards actually, and the final product also is assured actually. So it comes with a quality stamp, okay, and you can make you can quickly lay the concrete. The pumping rates are high actually. You can lay the concrete faster, do your structure faster. Also, you can give specific requirements. For example, nowadays we receive that I want 4-day strength like this, 5-day strength like this, 3-day strength has to be of a specific strength. 3-day concrete has to have a strength in 3 days, specific strengths like this. So these kind of all these kind of requirements can be easily taken care by a ready-mix company, and there is no kind of you need not have to store aggregates or sand or cement in your yard or on road or something like that, disturbing the traffic. Most importantly, as I said, you just order and can be rest assured that you are getting the best quality of concrete. So that is the main advantage of uh, ready-mix concrete. What is the main difference? Main difference is, most important point is when you are doing a site mix, your water cement ratio is a question mark actually. Water cement ratio is the one which governs the strength of concrete and not the cement content actually. You may have a very good mix design where they might have told you put so many bags of cement, or one bag of cement you have to use like this, okay, but here what happens is water cement ratio is left to the hands of some unskilled labor. They will just look at the workability and go on increasing the water cement ratio or water content, and hence they totally dilute the durability properties of concrete. Whereas if you are giving the order to a ready-mix company, water cement ratio is controlled. It comes with a full stamp of quality. There is a set of people working on quality QA system actually to ensure everything is done right actually. Please guide on redosing concrete on site. Is it advisable and how it is effective? Mr. Mahesh Tandulkar, thank you very much for this question actually. See, redosing is applied when the truck reaches site a little later actually. For example, let us say we have designed the concrete for a travel time of 2 hours actually. Let us say because of the traffic it reaches at 2.5 hours. Then this lump, instead of say 120 mm, instead of reaching at 120 mm at site, it can reach maybe 90 mm or 80 mm, and pumping may be difficult actually, or even sometimes lesser than this 80 mm. So here what we need to do is you can add about 0.05 to 0.1% by weight of cement content. So what you can do is you can take about 0.5 to 1 liter or 1 kg of admixture, and this 1 kg of admixture can be diluted in about 5 to 10 liters of water. and it can be put into the back of the truck, and the truck is turned for several revolutions, maybe for about 2 minutes actually, or 3 minutes, until a uniform mix is got actually. And then this method of boosting slump can be done with a class F admixture or type of admixture C as per C494, where the superplasticizer will have only a function of boosting the slump or increasing the slump, or it will not affect the setting time of concrete. So you dilute this admixture in water and put it on back of the truck actually, and turn it and take it actually. And most important point understand here is um, higher grades of concrete. As we have asked the question for higher grades of concrete here, the cement content will be say 450 kg plus microsilica or whatever it is. Okay, they will be more sensitive to changes in admixture dosage, especially at end dosage actually. So we need to just see and add this admixture, and we need to see that uh, there should not be segregation. There should not be segregation. Also, another point we need to understand here is we cannot go on adding this admixture several times. Normally, 2 times is recommended. Once you have boosted this slump actually by using a chemical admixture on site, you can do another time. Okay, you cannot go on doing and disturbing the concrete. Generally, we have this concrete time 2 hours given by IS 4926. What it means is, once the water comes in touch with cement, you need to use this concrete in 2 hours, unless otherwise you are using a superplasticizer cum retarder, or you are using the concrete in cold temperatures. This is given by IS 4926. Okay, so if the truck reaches site, there is also another point given in 4926 that once the truck reaches the site, it has to be unloaded within 30 minutes actually. So if the truck reaches at, say, let us say 2 hours, you can unload in 2.5 hours. You can measure the slump and boost the slump actually by using a chemical admixture. You can use a PC admixture also. You can use a PC admixture, boost the slump, but you should not use more of this admixture. It is maybe about 1 to 2 kgs dilution in 10 liters of water. That is all we can do actually. It all depends upon how much admixture is required to boost the slump from what slump to what slump. For example, is all depends upon the cementitious content and the ambient temperature and so many other factors. So there is no constant rule actually. Some people will say for every 25 mm slump, you use half a liter boosting of slump by about half a liter, like this and all. So it is not very easy to exactly tell, but generally, as a thumb rule, as per our experience, we can say 1 liter to 2 kg, 1 to 2 kgs of admixture diluted in 10 liters. Why we have to do dilution is it cannot reach the 15 tons or 14 tons. Okay, just if you directly put, it cannot spread completely, and uniform mixture cannot be made. That is the reason we say you can use 1 to 2 kgs of admixture in dilution with about 10 liters of water. I hope I have clarified, Mr. Tandulkar ji. Yeah. How to check the temperature of concrete? Very simple. You have to take. There are special thermometers for checking the temperature of concrete. Actually, it will be having a steel case. Actually, it will be having a steel case. Using that, you can check the temperature of concrete. What Vishweshwariya Sulikeri is asking another. What grade of concrete has to be used in industrial floor? See, industrial floors abroad they use M35 to M40 actually, M35 to M40, and we need to consult the structural engineer. What loads are coming and what is the purpose. We generally have to consult the structural engineer, but abroad it is M35 to M40 actually. What factor of is more crucial? if the cube strength variation against a set of cubes is more than 15%. Mr. Mukund Deshpande. Most important factor here, 15% variation on the mean as per as if we are taking three cubes and taking a mean, and there should not be variation from the mean. Each individual cube should not vary more than 15%. So here the biggest contributor is the costing. If the costing is not done properly, sampling is not done properly, remixing is not done properly, these three factors major role in taking giving such a erratic result. There are some people who say, for example, IS code clearly lays a particular point actually where they say one sample is equal to 3 cubes. Okay, when we are making ready-mix concrete as per 4926, every 50 meter cube or 50 batches, whichever is less, we have to take one sample. So what is the meaning of one sample? One sample means 3 cubes for 28 days. 3 cubes for 28 days. Okay, and these 3 cubes average will give one result. One result. So 7 days also we take. Generally we take 7 days 3 cubes, 28 days 3 cubes. Okay, here there are some customers who will say you take one truck, every truck 1 cube, and every truck one truck 2 cubes, another cube in another truck. All these things some people will say actually. If all these things are done, then there will be this also a problem where it will contribute to variation within a set. A set of cubes is 3 cubes taken from the same truck, taken from the same sampled as per procedure which we have already discussed. Either you use a IS procedure at what we discussed actually, you have to leave 0.3 cubic meters first, and then you take, or better is you follow a BSEN procedure where you have to leave 1 meter cube in the beginning and 1 meter cube at the end, and you take the sample in between. If we take the sample right, if we cast the cubes properly, remix these cubes properly, this 15% will not come. Casting technicians should be trained well actually. Technicians are very important, who have to ensure this particular percentage should be lesser than 15%. Please enlighten about FRC and recent innovation in HPC. Mr. Suresh Srinivas here. I think it will take a long time. Probably you can write a mail or we'll write to you actually. Main factors affecting slump retention. Mr. Pramod Sanketi is asking main factors affecting slump retention. Slump retention is affected by water cement ratio. Slump retention is affected by cement content, total cement content. If it is more, slump is less, retention is less. Slump retention is also affected by different brands of cement. Actually, one brand may give more retention, one brand of cement may give lesser cement. Slump retention is affected by the type of chemical admixture and dosage of chemical admixture. Higher the dosage, more the retention is. And then cementitious, presence of supplementary cementitious metal. If you include supplementary cementitious metal like fly ash or GGBS, slump retention is more. These are some of the factors of which will affect the slump retention. Mr. Srinivas Babu, for higher grades of concrete becomes sticky. That are what are the reasons? Mr. Srinivas Babu, whenever we are using higher grades of concrete, like say M50 and above, especially in conjunction with PC based admixture, whenever we are doing concretes with a higher dosage with lower water cement ratios, this especially the PC admixtures give this sticky concrete actually, sticky concrete. So the one of the things that you can do is to reduce the stickiness. Simplest method that you can do is reduce the cementitious content if possible. reduce the sand content if possible. Third one is also to change the admixture. Some of the admixture formulations give very high stickiness actually. So you can also change the admixture type or brand actually. So basically you need to have a certain water cement ratio. If you go below a certain water cement ratio, stickiness comes actually. So to avoid that one, you need to have, if you have very high cementitious content, you have stickiness actually. Okay. Uh, you have sometimes GGBS mixes with high total cementitious content. If it is more, GGBS mixes will also give this kind of property actually. And most importantly, you need to consult or discuss with the admixture manufacturer if there is any possibility of reducing the stickiness. They can also do this actually. Mr. Sanjot Chutneys is asking, can you suggest any statistical software for mix optimization like QSIM? Uh, there are some softwares available outside actually, means not in India actually. Um, these softwares are available. But as I said, before we implement this QSIM system actually, we need to be really studying whether it is really required for your operations. If you have too many plants and if you need to do this, you can do this. But at the same time, you need to be you need to understand very simple fact actually that each QSM system will guide a particular family of mixes. Particular family of mix. For example, OPC GGBS mix. For example, you take that will have a different family of mix. OPC fly ash is different mix. OPC mix is different, and then you have in OPC GGBS mix itself different proportions. 35 is to 65, 35% GGBS, 65% OPC. That mix, if you are feeding into QSM system, it should not include another mix which is 50-50. Okay, so these things have to be controlled, and most importantly, uniformity in the inward materials is important. If your inward materials are not uniform, and you are getting completely variable results, and you are changing cements and brands, different brands. If you are not using same brand, you are changing the brands, sources, and all. This kind of statistical software is of no use actually. So we need to be first understand whether we want to go for this kind of thing. But a lot of systems are available. Uh, kindly, Mr. Sanjot Chetnis, kindly write to me. We will discuss, and I can write to you back. Shivakumar Kandaswamy. Mr. Shivakumar Kandaswamy, is it necessary to monitor temperature of cement? Definitely, it is essential to monitor temperature of cement, especially in a ready mix company or big project site actually. Sometimes what happens is you have some 50 tons of cement in the silo, okay, and then another truck comes actually. Another truck comes and it directly fills up. Directly puts the, means you directly put the new fresh cement into the silo, and let us say you start using this one, and let us assume that the cement has come directly from the plant without stoppages in a very short time, within say 24 hours or something like that. In that case, the temperature of cement sometimes can be very high. Sometimes we have seen temperatures of cement more than 60 degrees or something like that. So if the temperature of cement is very high, then you will face a slump retention problem. You have initial slump itself may be a problem. So it is better to monitor the cement temperature before you start production of concrete, just to be sure of slump reduction. Otherwise, you definitely sometimes get into this initial slump itself will be a problem, and slump reduction problems can occur. Sometimes we find 7-day strength achieved but 28 days strength remains same. Mr. Siddharth Shah is asking this question actually. Many times what happens is, let us say we have cost, somebody has cost set of cubes, set of 3 cubes. So the general acceptable or expected variation within the set of 3 cubes is about 2 to 3 MPa, 2 MPa or 1.5 MPa, 2 MPa. If the everything goes well, you will be having there will be a variation of 2 to 3 MPa variation between cube to cube in a set of 3 cubes. Okay. Now let us say we have used OPC. Let us say we have used OPC, and OPC fineness is more generally now 53 grades. Most of the strength is achieved in 28 days. For example, 95 to 100% of the potential strength of concrete is achieved in 28 days itself. There will be not much growth after 28 days in the case of OPC. So let us say the strength has been already achieved in 7 days. Okay, so, amount of strength which is achieved in 7 days, maybe let us say for a M25 grade of concrete, we have achieved about 32 in 7 days itself, or 30 in 7 days itself. Okay. So if the cubes are not cast well, if the cubes are not cured well, there will not be much gain, especially in the case of OPC mixes, where the rate of gain of strength is very fast in many cases, especially if the curing temperature is very high. For example, now the summer is started actually in India. You have summer temperatures maybe between about 30 to 40 degrees. Okay, if you are not taking care of the curing water temperature 27 plus or minus 2 degrees, if the curing is done at high elevated temperatures, 7 days strength itself, in 7 days itself the reactions are faster, hydration is very faster, it might have achieved already 95 to 100%. Okay, there may be limited gain after 7 days. Also you add with that the variation in casting of cubes and sampling and testing and all. So that is why sometimes you find not much gain in strength in some cases actually. Okay, that is the reason. Especially this happens in OPC mixes. Siddharth Shah is asking what should be the dosage of admixture for PQC. See, the dosage of admixture is always is dependent on the type of cement and so many factors actually. Okay, and you can see SNF generally, of course, SNF is becoming almost an outdated product actually. SNF generally for PQC is used between about say 0.8 to 1.2 or 1.3% for PQC. But PC, if you are talking about PC for PQC, the dosage may be between 0.4 to 0.6%. Again, as I said, it has to be determined by trials actually. Mr. 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 Jamal Hussain, Muhammad Jamal Hussain is asking, suppose if we add any solution, bacterial solution to the concrete, do we need to reduce the quantity of water required? Mr. Jamal, I think you are talking about something related to self-healing concrete actually. I believe we have to talk separately, and I don't think we can talk now about this now. Right? Very ideal set of procedures. Thanks to your efforts to bring this to form. Thanks a lot, sir. Nagendra Kumar, sir. Thanks a lot. How to minimize variation in the slump retention? Mr. Amarnath Pandey is asking this question. Slump variation, if we want to minimize, we need to have same source of materials. First, if we do the trial, if we do the trial, once we do the trial and set all these materials, then we need to have same source of materials. We should not change at all. We should not change at all any of the ingredients. Okay, and we need to have a the travel time has to be exactly same actually. Okay, travel time has to be same, sources have to be same, water cement ratio control has to be of the top notch actually, and when the truck is traveling actually the revolution has to be least actually, same speed of revolution has to be maintained. The concrete has to be done in cold temperatures, uniform temperatures. If the temperature itself is varying, actually, the slump will vary actually. So these are some of the steps that we have to take care to minimize the variation in slump retention. Mr. Vishweshwarya Sulikeri is asking another question. What is the difference between FRC and general reinforced concrete is a construction material used throughout the world actually. When we are using fiber reinforced concrete, okay, fiber reinforced concrete can be an additional reinforcement. Okay, you have fibers, polyester fibers or steel fibers. Okay, these fibers are added as extra, added extra in the structural design in the RCC structure. Okay, to control the plastic shrinkage, settlement cracks, to increase the abrasion resistance, to increase the impact resistance, to increase the fatigue resistance, to also increase or maintain the fire rating. Fire rating is said to be better. Okay, to get all these important properties enhanced, there is also another point which improves by addition of fibers, which is shatter resistance. For example, bulletproof concretes are made with fibers actually. So general reinforcement concrete, what is general? It comes with some reinforcement as per the norms set by the structural engineer, and you are adding this as extra material, fiber reinforced concrete. Okay, there are other products which are devoid of reinforcement. Okay, that is different character. That is different kind of materials actually. Fiber reinforced cement matrix, fiber reinforced cement matrix. Okay, that is a different kind of materials that can be used for many other purposes actually. That is different actually. For structural purposes, mostly structural concrete blended with these fibers are used. Like to know the advantages and disadvantages of adding curing compounds in concrete. Mr. Srinivas Babu sir is asking this question actually. Mr. Srinivas Babu sir, there are two kinds of curing compounds actually. One curing compound which is once the concrete is done, uh, uh, as soon as the it reaches the final set time when the thumb impression cannot be done. Okay, as soon as it reaches the final set time, okay, between, you can say, between the initial setting and final set time, when the thumb impression cannot be formed, at that time you can apply this curing compound as a by spraying or by coating. Okay, mm, in this kind of material is used where you don't have access to water, especially for example tall chimneys or channels where in remote places water curing is difficult actually. Okay, and in some places, what happens is as soon as you have to apply this compound once the demolding takes place actually. Okay, the top surface is applied with curing compound, and the other surfaces, as soon as the demolding take place, at the earliest we need to apply this compound by spraying method or by brushing. We can apply this. This is surface application. What happens is it will reflect the sunlight, and it keeps the temperature of concrete cooler. The evaporational losses are reduced actually. The other kind of curing compound is the other kind of curing compound. The disadvantage of this kind of application, external application, is that the efficiency of this is said to be between 80 to 90%. Okay, against natural water curing. So it cannot give the full strength of concrete as uh, equal to normal water curing actually. So the point here we note is there should be we will sacrifice some amount of strength actually, potential strength. The other point which we want to tell you is once we apply this kind of curing compound on surface, no, we have to scrape off actually. We have to scrape off. Okay, otherwise plaster and other materials next coats cannot come and adhere to this concrete actually. So these are the disadvantages of a curing compound. But there is an integral curing compound which are not here in India. Integral curing compound are being used in US and other places actually, which are admixtures added along with the concrete during the manufacturing of concrete. So this kind of concretes here, many cases there is not much disadvantage. Only thing you need to talk about here is the cost here. Okay, and it is not economical at this point of time, and it is not used everywhere. It is not still popular. Okay, so there are two compounds. One is externally applied, sprayed or brush applied curing compound. The other one is internally added curing compound. Sir, can we use more quantity of GGBS than cement in preparation of concrete? Mr. Vishweshwaraya Solikeri. See, as per IS, it recommends 35 to 70% of usage of GGBS in concrete actually. So, if we are using more than this, then it will not be regular structural concrete, and you are going away from the IS code, and you can use it with certain probably alkali activators or some other things. Okay, but you need to get approval from your customer or client, and you should have a lot of data on this actually. Okay, so uh, we don't have at this moment commercial experience in these kind of things actually. Um, Okay, in 1960s, from 1960s, people have done a lot of trials using high amount of GGBS in Russia. Okay, now from 1960s they have used. Okay, but commercial applications in India is limited actually. Lab levels, people have worked actually. So in short, at this point of time, we cannot use more quantity of GGBS than specified by IS standards actually at this moment actually for commercial applications. What higher grade of cement concrete have been used in India? Where in Mumbai, I remember people using M80 and 100. Um, for these, you are asking cement brand. Actually, I don't remember exactly. And if my memory serves me right, Gujarat Ambuja cement was used actually for making high grades above M80 and 100 actually. Okay, M80 and 100 was used in Mumbai actually. M80 they are used in Bangalore also. We have in lab trials we have done means trials have been done with Coromandel, ACC, and even Ultratech actually. So a lot of this concrete was produced in Mumbai, 80 and 100, and Gujarat Ambuja was used for this one. Thank you. Thanks to all. Some of your questions can be written to me actually, and my email ID is given actually. I will just give. Uh, my email ID is here. You can give, and also in our website we have our website where you can write question to our website. There is a section called Dr. Q. Actually, you can write here actually to get your answers actually. It has been an honor to me to speak to all of you. You have attended this webinar. Thanks to all of you. Thanks to all of you.